Hi everyone. Today's video I'm going to cover a topic that in itself may not seem that important, but it's actually a prerequisite to many of the future projects I'm going to do that involve either electrical, electronics, or computer engineering. And that is, how do you properly solder things, whether they're wires or components to a PCB board, without causing any problems or future failures. Also, if you find this video useful, again, I'll ask up front, please consider subscribing to my channel. It would really be helpful. Thank you. Okay, to get started with soldering, let me show you some of the tools of the trade. These two are classic pencil soldering irons, used well for many years, but they're meant primarily for small projects. This one actually I used in one of my jobs when I was a computer technician, and it was probably a newer model of this, and we didn't have to use a soldering iron that often, but occasionally. This soldering iron, same type, but a cheaper version of it, much cheaper. This one I think cost maybe about $5 or $6 at Radio Shack, and I bought it when I was training my kids when they were probably only 10 or 11 years old, how to do soldering. Primarily my sons, but my daughters were interested as well. I won't even plug this one in because I'm not even sure if it works anymore. But this one I did, and it actually does still work and can still solder extremely well. When I got into some serious work, I bought myself a soldering station, and this soldering station was extremely good. This here is probably about 25 years old right now. Still works fine. I tested it, but it's dated and it doesn't have a temperature sensor. It was very good at keeping a stable temperature though. So we pretty much knew that if you changed to the proper tip, because these tips are changeable, then you would get the temperature that you needed. And temperature is critical, as I'll say in a couple of minutes. It also has a little sponge pad built on it. This is the original one. This thing is like 25 years old. I just wet it before filming this, and it still works fine. Now, the station that I got recently, as I got it involved more in some of the more computer-based hobbies, is a more formal station. Believe it or not, this actually costs less than that Weller one, but they're much cheaper now. This one has temperature on it. In fact, I have it plugged in so I can turn it on, and you can see the actual temperature of the heat that this thing is actually going to generate for us. That's in degrees centigrade, and the soldering arm with the pencil on it is pretty accurate in terms of keeping that temperature. In addition to that, I bought a whole collection of tips for this, different tips for different purposes, from a very fine needle type tip to one that looks like a little blade, like a little knife. And there are different measurements to those tips that I'll show you in a couple of minutes as well. So the proper tip for the proper purpose for the proper soldering job. In addition to the soldering iron, you're going to need solder. For purposes of electronics, there are two major types that are used, and one is being phased out. This is a traditional one that I learned on as a kid. It's regular what's called 60-40, which means that it's actually 60% tin and 40% lead. This one is still here. I haven't used it in a couple of years now because I've made the complete transition over to leadless. This is sort of a tin silver alloy that does not have any lead in it. They both have what's called flux in the core of it. But if you were to look at it under a microscope, you would see that the tube is hollow. And in there is paste called flux, which, by the way, I have here. And I'll show you how that works when I'm giving a demonstration in a couple of minutes. Like I said, this one's being phased out. The one with lead, obviously, there's dangers associated with that. Breathing in the smoke from burning it has actually caused some people to get minor lead poisoning. So this is not the way to go. The real difference on these two, and there were advantages to the lead one, it actually can melt at a much lower temperature. Now that's a good and a bad. It made soldering with some of the lower inexpensive soldering irons like this one work extremely well. Today, you should always get a nice soldering station anyway where you can get the temperatures that you need. The difficulty to this, of course, is if you're dealing with semiconductors or transistors, diodes, and other semiconductor type devices, the extra heat could be a danger to them. You could actually ruin them. In addition to this, you're going to need some additional tools. I like to use one of these. Rather cheap. You get it for like $8 or $9 from Amazon, even cheaper if you go to Harbor Freight. It has two clips on it. It has a magnifying glass. It has a nice base to it. And you can hold your work, whether those are wires or board or something that you wish to work on. The two clips can hold both ends of it and keep it steady for you to solder it properly. A more advanced tool, just designed for printed circuit boards, is this here. This will allow you to put a printed circuit board. It has special connectors on it that are meant to hold the printed circuit boards on both ends. You can adjust its length. You can lock it in place. It has a nice foundation to it. And this allows you to work on a printed circuit board. For example, here's a sample printed circuit board right here. If I wanted to show how this would work, I could actually take this, I could open it up, put it inside the place, lock it in place. I could actually work on this PC board using this jig. And if I'm soldering, I could actually take the soldering iron and I could solder connections right onto this little PC board. Very easily, very easy to see it. Makes it much more convenient than trying to lay it down, especially since most of the components you put on this would actually stick out the other end. So this prevents you from pushing the components in too far, especially things like transistors and diodes, which you need to have a little bit away from the circuit board on the other side of it. Just standing away from it, probably about the tip of a screwdriver, a small screwdriver. Other tools and supplies are, we need a nice pair of diagonal cutters. I like to use the same ones I use for dealing with tie wraps and putting a computer together. These work extremely well, small wires. If I need something with a bit more leverage to it, I can go with a larger diagonal cutter. These are two different size diagonal cutters that you could also use, depending on what you're trying to do. This is for the heavy duty stuff, which I'll show you in a couple of minutes. And you also need needle nose pliers, same thing. This is generally the size you'd be looking for small electronic work. But if you need to do the heavy duty wires, you can go ahead and get a much bigger one than that. Dealing with electrical wiring and some of the larger gauge wires, you'll need something like this to bend them around. And the most important tool is a wire stripper. Now there are a lot of different wire strippers to choose from. You have these traditional wire strippers which actually have gauge wire indicators on it for the actual gauge of the wire, and you put them into the appropriate place, close it, and you pull through and it strips it. These I find to be a little bit clumsy for dealing with delicate work. These are good for like electrical wires that you're putting in a new outlet in your home, but for small wires this doesn't work too well for me. I find these to be much better. You can adjust these to whatever size gauge you want. There's an adjustment screw here. It has nice spring load action to it. Very, very sharp cutters. Once you get a feel for it, you don't even have to adjust it. You can actually feel when you put the wire through when it pierces the outer layer of the insulation, and then you just back off a little bit and you can pull the wire right through. So I love these. Let's say I wanted to strip this wire. I could just take it, put it in the front here. Let's say I want this much stripped off. I push it a little bit and then I give it a little twist and then I just pull it out. And that's stripped nice and clean. If you go too deep, you could actually tear off some of the interior wires if it's one that's not solid. So you got to be careful of that. Now let's talk about soldering itself. On the screen right now, you'll see a soldering temperature chart that I created based upon my experience and some information that I got from the various manufacturers of the soldering iron. And I put it all together in one place. You'll see there's a column. The left-hand column is what the temperature is in degrees centigrade. What's shown on my latest soldering station. That soldering station actually supports temperatures from 200 degrees centigrade up to 480 degrees centigrade. So this is pretty much in line with that. Although this chart is really independent of that. That whole range up to 500 is considered the area that you would want to do soldering at, as opposed to getting into something like brazing or welding. The next column does the conversion to degrees Fahrenheit, just in case you're interested. So you're talking about temperatures from just under 400 degrees to as high as over 900 degrees. And then I've indicated the two solder types. The first column is what the lead-free solder does. It has to have a much higher melting point in order to do soldering. And I've also indicated in that column what gauge wires you will need those temperatures for. Column to the right of that, the 60-40, is for the 60-40, which is 60% tin, 40% lead. The 60-40 has a lower melting point by, about 80 degrees or so, 70, 80 degrees. I reflected that in this chart. And I've never tried anything larger than 4 gauge. I have tried 4 gauge. It is doable. It takes a lot of time, though, to get that up to the heat level. Once you get past that, you should really be doing the soldering with a torch, similar to what you would use for plumbing. And then the final column that I have tip is the millimeters measurement of the very fine point of the tip. the ones I showed you a couple of minutes ago pretty much fit into most of these millimeters. Back to soldering here. Let's start off by taking a look at the wire gauges. So what I have on the table here are sample wire. So I have everything in this chart from 6 gauge up to 28 gauge. I don't have all of the choices in between, and not all of them are wire. I actually have resistors here. For example, this resistor, which is 1/8 of a watt, that's a 28 gauge wires that are actually on that resistor, very fine. And this one here is a 1/4 watt resistor. But I have then wires as well under these. So example, I have this yellow wire is also a 22 gauge, just like the resistor. This is the standard wire you will see in computer applications, and the one you'll see me using the most. I have this in a whole variety of colors, spooled in one kit that I'll show you later. Then we go into wires. The 16 gauge is very popular. It is the one I would use for power supplies. In my experimenter that I showed in a previous video, this is the wire that I used for the AC. So it can handle actually 15 amps, as I've indicated up here, of current. Then I have a 20 gauge. This is one that's a higher power than the 15 amp. It'll go 20 amp. So it's a bit thicker. And I only use this wire on my experimenter on the incoming AC. Then these next 3 are really household wiring type. Anyway, I just wanted to show you a sampling of the different ones. Now let's try this. Let me get the soldering iron going. And I'm going to be actually wiring up 2 of the 16 gauge wires. So for 16 gauge, the best heat for that with non-lead solder is going to be in the range of 390 to 430. So I'll pick the middle number, 410 degrees centigrade. So let's pump this thing up to 410, close enough, 412. So we got that up to its temperature. Once at its temperature, it stops moving. When you first turn it on, it shows you the temperature that the tip is, and you go ahead and you tweak it up to the temperature you want. Actually, I could do the demonstration. I'll go ahead and put the little piece that I have of the 14 gauge together with the 16. So it shows that you can put different ones together. So the first thing we want to do is we take the 2 ends of it, and I like to tin them first, each individually. So I twist the wire. I hold on to the actual open end wire, and I twist the whole thing until the actual ends of the wire are twisted together. I do that for both of them. I grab here and I twist together. Then this is where I use my flux. I will dip the ends of both of these into the flux. Flux keeps the metal clean for the soldering iron and the solder to adhere to. So I'll do each one of them like that. I'll put it in here and dip it into the flux. The reason it looks the way it is, you'll see in a minute. Then I take both ends. Don't worry, the flux is not going to hurt you. It's made from a vegetable as far as I recall. I'll take these 2 wires and I'll put them like a little V, and then I will twist them together. And if needed, I will take diagonal pliers and I will give it a little bit of a helping hand if it's thick wire like that. So I can take it and twist it together. I dip it again one more time in the flux so I get the outer edge too. Now I'll put the 2 ends of this inside of the jig. So you can actually see the 2 wires together right now in the jig. Take the soldering iron tip, and I take the tip now and I dip it in the flux as well. So I'll take the flux here and I'll dip the tip into it. Get a little bit of smoke, don't worry. I'll take my lead-free solder and then I heat up. And I should be using a bigger tip, so we'll see how this goes. It'll still work, it'll just take a lot longer. But I'd rather not change the tip right now. And I'll go ahead and you hold it onto the wire and you heat that up first. And then when the wire is heated, you just melt the solder onto the wire. So it takes a lot longer with this tip because it's not the one meant for this gauge wire. So as you can see, it still works, but it just takes a lot longer. And you want to make sure it all melts in properly. Don't go too long or the insulation starts to melt off. So now this looks like it's a very solid connection at this point. As you can see, it has a little bit of a shine to it. That's what you want to see. If it looks too dull, then that's what we call a cold solder joint. This one is not. It has a nice little shine to it. Now that's another advantage of the leaded solder, by the way. The leaded solder will actually have the advantage of it will shine a lot more. So it's a little bit easier to tell what's going on. Is this how we're going to leave it? Honestly, this is not how we're going to leave it. I am going to take these wires, and I like to do it this way. Other people like to put the two wires together and blend them. I like this, and then I bend it over, and I bend the entire large part of it over onto the smaller wire. So when you have two wires of a different size, you bend it on top like that. And then I take the other thing that I didn't show you yet, and that's the heat shrinkable tubing. I have a whole package of them. And I pick the tubing that's the closest to the size of this joint. And I believe this will be it. This black piece is already cut. I don't have to cut it. So I'll take the diagonal cutters and I will actually cut a little section off like that at an angle. And when I cut that off, then I'll be able to have a nice angle to that. Doesn't hurt the integrity of it as long as you just do the tip of it. And then I'll be able to get this on more effectively, and I can then get it right across. Now, what do you do at this point? Well, there's a lot of ways to deal with this. Some people like to just use their soldering iron, because the heat from the barrel of the soldering iron will do it. You have to hold it like really close to do that, and it will work. I like to use a heat gun normally. So I have a heat gun that I use for other purposes, and I use the heat gun to do it. It goes a lot quicker that way. But if you just hold it above the barrel of the soldering iron, it will eventually shrink. Try not to touch it to it, or you could damage the insulation. So as you hold this here, you start to see that it's shrinking, and it'll make a nice tight wrap right around the wires. You could also take a match to it, and then that's the final joint. You can actually see where it has formed to the wire connection inside of it. Let's say that you want to connect stuff up to a printed circuit board. So I'm going to put these two resistors that I have shown you earlier onto a printed circuit board, and I'm going to show you how to appropriately solder those to the printed circuit board. So we're going to use this little printed circuit board right here. So the first thing I want to do is put the components onto it. Now I could put it in this thing first and do both. Make sure you press it together, and you can tighten it up in there. It'll stay in place. So let's say I've already outlined a circuit on this, and in a future project you'll see me use something like this to actually make a real project. But just for purposes of demonstration, let me start with the quarter-watt one first. Figure out what two holes you need to go to, and this is where the diagonal pliers come in handy. Bend it by putting the diagonal pliers here first, and then take your finger and bend it down like so. And do it to the other side. Put the diagonal pliers there first, and then bend it down. I'm assuming that I measured it out to the right holes that I wanted to do, so we'll pick end holes right here that match it up. So I push it in here at one end, and then we can turn the whole thing over. I like to take the wires and bend them out just enough to hold it in place. That way the resistor does not fall out, or whatever component that you have there will not fall out. So now these are bent appropriately. Now I'm going to solder them in. So what I'm going to be soldering is 28 gauge wire. 28 gauge wire is about, I'm going to take the middle of the road to about 270 degrees centigrade. So I'm going to set this soldering iron to that temperature, 270 degrees. So now we take the soldering iron tip and I put it in the flux real quick, and I get the solder ready. I make sure I have the solder already unspooled, some solder out of it, so that I can use that to actually blend in with the joint. I take the soldering iron, I'm going to dip it in the sponge first down here. Clean off the tip because you do get some residue on it when it's heated up and cooled down. Cleaning it. Nice clean tip now. I dip it inside of the flux, just barely. Let me show it on the camera here. Then I take the joint I want to connect, and I put the soldering iron right in the joint. And I hold it there for a second. I heat it up, and then I feed in the solder. And I give enough solder to melt into the joint, hold it on for a couple of seconds longer, and pull it away. And if you look at what was done here, you will see a nice soldered joint, only touching that land and no other land. And if I clipped it off with the cutters, you will see a nice joint. I go all the way down to the base and I clip it off. And what's left is a perfectly soldered right here. It's not touching any of the other lands nearby. It's not a cold joint. It's not dull. It's a little bit shiny, which is what that particular type of solder will do. And I can move on to the next one. Take the soldering iron, clean the tip again in the sponge. I dip it into the flux and put it up to the joint, and then I feed the solder it's a nice clean joint. There's a nice solder joint that is not shorting out to any of the nearby lands. That's important. Always check that. Make sure that there's no shorts between that one and any of the nearby ones. Let me try the smaller one now. I have this one right next to the other one. So I am going to bend it over to it, and I'm going to solder that one on top of that one. So it's going to be a slightly different soldering job than I did over here. Plus I'm going to solder it to its own land as well for extra strength. So I'm going to do two solders, one to connect it up to the existing connection and the other one to connect it to its own connection. And then I'm going to solder this, one over here just to the LAN itself. Now what I'm going to do, I'm going to put a little bit of extra flux on it. So I'm going to take the flux and I'm going to use the solder to grab up some flux like this. So I got a little bit of flux at the end of that, and I'm going to use it to put flux on top of that joint. So now if I take a look at that, I have the two of them soldered together. This is the way you deal with these kind of boards that have the individual connections. If you want to connect something up, use the excess wire from a component to connect up. If it's a wire, make sure it's long enough that it's sticking through that you can wrap it down like that to touch the thing you want to solder. Have that joint connected too. So we have this resistor going from here to here, and another resistor going from right next to it down to there, and this is how it looks on the other side. And they are connected. Okay, what I went and did is I got an ohm meter. So I'm going to put the ohm meter on this and show you what the ohms are now that I've connected the two on the circuit board. So it should make sense. As I said before, I have 4.7K, 4700, and I have a 4.3K. They are now in series. So if I put this on here, let's see what ohm reading I get. I'll put the ohm meter at both ends of this, at one end of this one and one end of that one. And what do we see? We see a reading of 9.56 kiloohms, which is extremely close to the adding of these two. So we know they're connected in the circuit. Now the last thing I wanted to show you was also involving one more tool, solder remover, which I call a solder sucker. They're cheap, but they work extremely well. Rarely do you have to use them, but you always should have one handy just in case. So what I'm going to do, I'm going to fill in one more of these holes with solder. And I'm going to show you how the solder remover will work in removing the solder from that hole. So the first thing I need to do is solder in one of those holes. This one here, let's say. Okay, so now there's solder in that hole. I want to get that solder out. Nylon tip to it that lasts a long time, although it comes with extra tips. You push this forward until it locks in, creating air pressure in here. I then take the soldering iron, and I will do two things at once. I will heat the solder joint, and once it's nice and heat, I put this right on top of it. Put this right on top of it, and it sucks all of the solder out of the hole. Actually, in that case, I overheated it, so it actually took the actual lands with it, which is always a risk when you're trying to remove solder, so just be aware of that. So it actually took those two lands with it. Never perfect, so be aware. If you have to remove it, you could damage things. Well, that concludes my video on how to solder. I covered a few different objectives here, but hopefully if you do some practice with the things that I've shown you, you'll ultimately be able to do things with confidence and not worry about any failures in your equipment or producing something that doesn't work outright if you happen to need to use soldering skills to get it to work. Again, if you found something useful or just generally entertaining in this video, please do us a favor and subscribe to my channel. All you have to do is click on the little head here, and that'll take care of it. I'd really appreciate it. Thank you, and until the next time, take care.